So hi guys. So now we'll be solving a problem about thickness. So the given is the width of the Red Mountain sandstone near Bingham, Alabama was found to be 175, measured along a south 67 east direction from a lower elevation to a higher exposed Red Mountain formation, with the ends of the traverse being the contacts with an underlying sandstone unit, and an overlaying shale unit. A strike and true dip of bedding are not available, but two apparent dips along bedding planes have been measured: 33 degrees north 47 east and 46 south 56 east. Find the true thickness of Red Mountain unit. Use any preferred method to solve for the strike and true dip of the unit. So first we will solve for the strike. Then after the strike, we can get a true dip. And from that, we will be solving the thickness. So how will we solve this? So the first thing that we will do is that we will create a Cartesian plane first. This Cartesian plane. What we will do next is we will plot the two apparent tips that are given. So from here, first we have north 47 east. So we will measure 47 degrees from north going to east. 1, 2, 3, 4 is 7. This is north 47 east. And the next apparent dip is south 56 east. So we will measure 56 from south going to east. So 1, 2, 3, 4, 5. Here. We'll connect it to the origin. This is our south 56 east. Next is we will now plot the given angles of the corresponding or the respective uh, directions. So for north 47 east, we have 33. For 56, south 56 east, we have 46. So first we will plot the angle of this. Let's count 33. 2, 3, here. 33. And 47, 46 rather, going here. Always remember that our angles should never intersect from one another. 46. This is 46. Now, next thing that we will do is we will plot a line. I rather first we will measure any length from either of the two apparent dips, so we can use this or this. So what does that mean is that we will be measuring a specific length for the thickness of this apparent tip direction, or apparent tip rather. So how will we measure it? We will be measuring the thickness of this. So we need a line that is perpendicular from this apparent tip direction. So let's say we will use this. We will measure a length that is perpendicular from this one. So it's like this. Let's have at least 2 centimeters. Always remember that the length that we will measure is perpendicular to your apparent deep direction, which is this one. Should always, ha? So this is 2 centimeters. Since we have 2 centimeters here, we will be also plotting 2 centimeters from this one. But always remember that it is perpendicular to your apparent deep direction. So, for this, we will measure 2 centimeters and at the same time perpendicular to this apparent deep direction. So, we will plot 2 centimeters over here. So, that is 2 centimeters. Now, the next thing that we will do is we will connect these intersections, this and this. So, we will connect these two lines. Like that. And now that we've connected these lines, we can now say that this is a line parallel to our strike, or it could also be our strike. So we will measure this, the angle of this line. So it's at least 7. It is 7 degrees. So if we will look at the trend of our apparent dips, it's going here, right? So let's, before we clarify that, we will first um, plot the 7 degrees. Five, oh, my mistake. It's not actually 7, but it's actually 12. 12. Is it 12? It's 12. So uh, these lines are now perpendicular, are parallel to each other. So let's just assume, since this is not very accurate, but these are parallel to one another. So these are now your strike. So now what strike will we use? This one or this one? If we follow the right hand rule, since our apparent dips are going in this way, and if we use right hand rule, we should be using this strike and not this strike. Since if we use this, the apparent dip should be over here. So we will use this, and from here we will measure 90 degrees to get our true dip. So from here, we will measure 90. like that. So this is our true deep direction. So this is our strike. So our strike is north 12 degrees east. Our true dip is 1. Now what is our alpha? Our alpha is the angle of the apparent dips. So we will just choose 1 from one another. So we will use 33. And our beta is the difference of your apparent dip direction to your strike. So if our strike is this is 12 and our true apparent dip direction is 47, 47 minus 12 is 35. 35. So we will now substitute the values. Tangent 33, sine 35. Our angle is 48.55. So that is now our angle, our true deep angle. Now, how will we use this to solve for the thickness? So, if we visualize a bed, it's like this one. This is a bed that is tilted. How will we measure the thickness? So the thickness is not measured like this, but like this, like this. So if we look back at the problem, we can say that was found to be 175 measured along direction. So the 175 that is given is this part. This is the 175. And since the angle of our bed is this, this is 48.55. Now, how will we know the values of the other, the adjacent and the opposite? So now we will be using, so we don't need the adjacent, but for us to solve this length, this one, since this is the thickness, we'll be using sine or so. So we all know opposite hypotenuse. So we substitute the values opposite. The opposite is the missing value since this is the opposite of 48.55, the opposite of the angle. So our 175 is the hypotenuse. This should be 48.55. So now how will we solve this? Let's cross multiply. So 175 sine 4855 is equivalent to uh wait 175. No, we will not cross multiply. Yeah, I'm just confused. So we will just cross multiply it. So it's actually it's right. So for us to solve that, we will. So what I did, okay, let's clarify it one more time. So for us to solve the thickness, if we visualize the tilted bed, this is a tilted bed, In the problem, it was measured to be 175. And we all know that if this is a triangle, this is the 175, we can say that that is the hypotenuse because it's the longest side. And this is the opposite since it is the opposite of the angle that is given. And the angle that is used is the true dip that we have solved. So we can say that this is the opposite side. So what we will do is that we will use the saw for the SOHCAHTOA. So for saw, we have sine opposite over hypotenuse. So our hypotenuse is the given value, okay? Always remember. Our opposite is the opposite of the angle, that is the true dip. So we will substitute 48.55 here. Opposite is still unknown, and 175 which is the hypotenuse. We will cross multiply and we'll go into uh, this part. So since we already have the values, we will plot the values onto the calculator. And we are given 131.17 meters. So, based on the solving, this is the thickness of our bed. Okay, let's run through this one more time. So, this is the bed. This is the bed, right? It is tilted in this direction, in this trend. So, our true deep direction is always here. This is the angle of the tilt of your bed. And the 175 is the top layer. So now we have the 175 here. The one that we will measure is the this this vertical thickness or the thickness of this bed. So if we look at this, the triangle, we look at the triangle, it is the opposite of the angle. So we will use SOH or saw, and we will substitute the values, and then when we isolate opposite or the x, we will get this value. I hope you understand it, and that's it for the thickness.